Okay, let's do queues now. Okay, so queues are another ADT, and they are as simple as stack except with the circular version of it. So queues may the data is sent in first in first out manner. Okay, this is exactly how you queue up in your daily life for when you have to purchase something, when you have to go to a restaurant. So you have person one, person two, person three, person four, and let's say here you have a table of maybe some bottles that you have to purchase. So maybe some items are there, so everybody's lined up. So person one will go, and then once they are done, then they will leave the queue. Then person two will take their place. If they are done, they will leave the queue, so on and so forth. So every time a new person has to be added into the queue, they will be going at the tail of the queue. Okay, so this would be the tail. This is where the new values would be added. And then if the person has to go out of the queue, then they would be removed from the head of the queue. So when person one is gone, they are removed from the head of the queue. When person two is gone, they are removed from the head of the queue. So every time you remove a person, you'll basically be incrementing the head of value by one. And every time you add a person, you'll also be incrementing the tail by one. So this is the whole idea of queues. Now there are two queues. There is a linear queue, and then there is the circular queue. So पहले हम linear queue को देखते हैं, and then we'll look at the circular queue. They're both very, very simple. So let's talk about the linear queue first. Very simple concept. So what happens in linear queue? Let's say you have an array of values. Let's stick to 5 values for now. Okay, index 0, 1, 2, 3, 4. Okay, so you have 5 values in here. Initially, okay, अब इसमें भी multiple assumptions आपकी जो हो सकती हैं. Sometimes they might ask you that the head is starting from -1 and then tail is starting from 0. And this is actually a question in the past papers, and there was this very common mistake. I remember reading the exam report, and it said that only a few students figured this out. So the issue was कि जब आपने tail 0 पे start किया and you put in a person here, let's say you put person A into the queue. So as soon as person A becomes part of the queue, then the head should also point to 0 now, right? Because person A has to eventually leave the queue. But 99% of the students forgot this step and they kept head pointed to -1. Okay? So you have to be very careful with these initializations. They are a very big hint into how the queue or the ADT is going to operate. So when you add a value into the queue, so that means कि उस value को आपने remove भी करना है. So your head and tails should be in sync when you have to do something like this. So there could be multiple implementations. Okay, let's start with this implementation. Maybe where head is set to this and tail is set to 0. Head is set to -1. So our head is at -1 and then the tail is set to 0. Okay, so we add a person A. Now head should also be pointing to 0. So head becomes 0. Then we add some new persons. Maybe I add a person B, then a person C. So the tail of the queue is moving along. So tail is here right now. This is tail. Tail is at index 3. And head is still at index 0. This is where the head is. So head is pointing to, you can say, index 0. This is the head pointer. Okay, now what will happen is if I want to add another value into the queue, so again, I will first increment the tail by 1 and then I'll add the value, let's say D. And then if I want to add another value into the queue, I'll again increment the tail by 1 and then I'll add that person into the queue. Now, if I want to remove, so इसमें अब दो functions होते हैं आपके पास. There is one is called NQ and the other one is called DQ. So you have the NQ function where you add in a value, and then in the DQ function you remove from the value. So now I want to remove the value. So tail and the head is pointing at index 0. So what I have to do is I simply have to save the value A, and for now you can imagine that value of A is gone, right? So head moves to index 1 now. So this is where the head is pointing now. Then let's say you remove the value at index 1 now. So B is gone, and then you move the value of head to index 2. Right? So अब इसमें जो आपके empty और full की क्या जो है condition होगी in this scenario. This scenario in this scenario we assumed that head was equal to -1 and tail was equal to 0. Okay, this is only for this specific scenario, so इसको आपने mix नहीं करना. Okay, जब आपकी so when would your Q be empty? So if the tail is already pointing to 0 and head is pointing to -1, so what will happen is um, if there is no value in the queue, so your head would already be pointing to -1. That would be the default assumption, because if you add a value, so tail अगर tail की value 0 है और आपने वहाँ पे value add कर दी है, so यहाँ पे there would be a value then, right? And then tail would go to index 1. So this is going to be the indication that your queue is empty when head is set to -1. Because if there comes a value into the array, then head would also point to 0 then, because we'll eventually have to remove the value. So this would be the, in this case, we will write when head is equal to -1. So that means that the queue is empty. Okay, when would the queue be full now? So when we keep on adding the values, eventually we reach the last index. जैसे हमने यहाँ पे e add किया था, so we were at index 0. We saved the value, we did 1, saved the value, did 1, saved the value, did 1, and then saved the value. And जब हम e index 4 पे आके if we put e and I do +1, so now the tail becomes 5. So the same logic as we did in stack. So यहाँ पे क्या होगा कि जो आपका जो tail है, it would become greater than the last index. Or you can say it would become equal to the size of the array, which in our case is 5, because length हमेशा 1 से start होती है. Right? So that's the whole idea. Again, the assumption was -1 and 0. अगर आपका head भी initially 0 से start होगा, so then the case would be a bit different. So अगर आपका head 0 से initially start हो रहा है और tail भी 0 से start हो रही है, so then you have to figure out, depending on the question, what you have to do. Okay. And yeah, so let's say if the head is also starting from 0, and then you put in a value here, and then tail goes to 1. So if you want to remove this value, so you have to first bring back the value of head on, bring back the, sorry, tail would remain there. So आपका head जो है उससे आपने value remove करनी है. So head is already at 0. So you remove the value and then you do -1. So head would again go to -1. So in दोनों cases में आपकी assumption same होगी. Okay, so depending on the context, again, this is very context specific. They can ask you multiple implementations in the exam. So this is linear queue in very simple terms. So going back to our collab file then. So back to the collab file. Now here we are assuming that our queue is of size 20. इसको भी हम 5 ही कर लेते हैं for now. And again, we will make it an integer array, or we can make it a string array. Let's make it a string array. So I'll say empty string for blank in range of size, like this. So we are setting queue tail to -1 and queue head to -1. So again, since we did the other implementation, हम उससे से करते हैं. So queue head, queue tail, I'm setting it to 0, and queue head, I'm setting it to -1. All right. First of all, we have the enqueue. So इसमें आपके पास ये तीनों global variables आ गए. You have the queue data, you have the queue head, you have the queue tail. Queue head data is the array that we're looking at. Then we're saying if queue tail is equal to size -1, then you have to return false. Otherwise, you have to return true. Okay, so in what case would the queue be full? So we discussed that. So जब हमारे केस में ये था कि आपकी queue जो वो size equal हो जाएगी, okay? जो tail है वो size equal हो जाएगा, and size is 5. So if you have 4 values, again you have, let's say, A, B, C, D, E. So index 0, 1, 2, 3, 4, 5. So when you exceed index 4, you go to index 5. That means that the queue is full now. Again, length starts from 1 and indices start from 0. So you have to keep that in mind. So in our case, if it becomes equal to size, we return false, and we can also print queue is full. इस तरह से. Otherwise, what we're going to do is, okay, so since we set the tail to 0, that means first we have to save the value. So I'll solve these. So first we save the value onto the tail of our queue, and then I increment the queue tail by 1. And then this again is a very important check here, जो मैंने आपको बताया था past paper question में था. So if the queue head was set to -1, and since we have added the value, now queue head should point to 0. Because now if you want to remove the value, it should be removed from the index 0, not from index -1, because -1 कोई valid index ही नहीं है. And then once you have done that, you return the value. true. So this is enqueue. And then in the dequeue function, we will do something similar. Okay, in the dequeue function, we again global these variables. So you can do them in comma separated manner as well, rather than writing them separately like this. And then you write if q head is less than 0. So as we discussed, आपका जो q head है जो -1 हो जाएगा, इसका मतलब है कि आपकी q empty है. Okay, so in that case your dequeue cannot happen. ये जो ये आगे हम सर्कुलर क्यू के केस में पढ़ते हैं, और q head becomes greater than q tail. Okay, so this also means that the queue is empty. Okay, now what is this condition suggesting? I think इसको हमने discuss नहीं किया as such. So let's quickly look at this. Okay, in this case, what will happen is, so we have 0, 1, 2, 3, 4, and we have A, B, and C. Okay, so we assume that the tail was starting at 0 and head was starting at -1. Okay, keeping that in mind, so this is where the tail is pointing at right now. The tail is at index 0, and sorry, this would be head. This would be the head pointer. So we start from index 0, we added A, then we did tail +1, then we added B, then we did tail +1, then we added C. So tail would technically be pointing at index 3. Now what I'll do is I'll simply call dequeue thrice, and let's see what happens. So when you call dequeue thrice, so the values would be removed from the head, right? So value of A is removed, head moves to index 1. Then dequeue and head moves to index 2. Then you dequeue and head moves to index 3 now. Okay, so in our case, in this specific case, when head has become equal to tail, this now means that your queue is empty, because head and tail, so this was tail, and now head is also pointing at 3. So in this case, it means that our queue has become empty because they're both pointing at the same index now. Okay, so this could also be the case. Not necessary कि initially जो आपकी state होगी वही रहेगी. So जब आप multiple times dequeue करोगे, तो there would come a point when the queue would become empty. And if you try to dequeue after this again, so what should happen is that head would exceed the tail, and head would now point to index 4. And this shouldn't happen in the first case, because इसके आगे कोई value नहीं है, so आप उसको remove कर नहीं सकते. So this is how we have to do it. And this was another case that is very important. So going back, so we have to check if q head becomes greater than or equal to the q tail, then you have to return false, or you can say return q is empty. Otherwise, what you have to do is you have to get the value that you are dequeuing, and then you increment the q head by 1, okay? And then you return the removed value. And इसमें याद रखिए क्योंकि stack में there is one pointer, so we're doing plus minus top, but queue में both pointers are incremented, +1 and for head and +1 for tail. Now let's try to run this. So I'll just assign random values into queue data, say A, B, C. Okay, and let's enqueue. Okay, we'll just do it from here directly. Enqueue, let's say A. Okay, it's returned me true because that means कि अभी आपकी queue में data insert हो गया, so queue data को साथ से print करते जाते हैं. So we have 1A, then I'll enqueue. I'll just print this. So I have B, and then I have C. Okay, perfect. So I have 3 values in the queue, perfectly aligned. Okay, now let's try to dequeue it. Dequeue like this, and then we'll print the value of the queue. So I run it once, twice, and thrice. Again, we are not removing the value. So for again this case, I'll just say queue data at the queue head. By the way, you don't need to name them this long. जो भी question paper में उसने नाम दिया होगा आपने वो use करना है. So let's put an X here. Okay. All right. So I dequeued thrice, and now all 3 values are gone. And if I try to dequeue again, it should be printing a message. Q becomes less than 0. Q head return Q is empty. Okay. We are not catching the result. So I'm just going to change it to print for now. Otherwise, we'll have to catch the result into a variable and print it. Now it says queue is empty. Okay, so I'll change this part, and just to show you the difference, now I have to get the value in the variable, and then I'll have to print the value in the variable because it's returning a value. So print, let's say y, and then let's say print x. Is the house. Okay, so it removed 3 values, and then it says queue is empty, so you cannot delete further values. That's it. So this is linear queue and stacks in very simple terms.